Today, I want to talk about the Illuminati. I want to talk about triangles. Maybe if we have time at the end, we could get to the Illuminati. This was a bad idea. Let's just talk about right triangles. Welcome to aritutorsmath. If we know that all triangles have 180 degrees and a right triangle has a 90-degree angle, we know that the other two angles have to add up to 90 degrees. When it comes to right triangles, we have this little section of math called trigonometry that talks all about right triangles and the relationships between the angles and the sides. What we're going to be doing today is looking at what trigonometry is, kind of what it teaches us about right triangles, and then we're going to be able to solve a couple of problems with it, solving for unknown sides or unknown angles using trigonometry. Let's imagine we have a right triangle, because that's what we're talking about. There's a lot of noise coming from the great outdoors. Let's imagine we have this right triangle. That'll be my right angle. We have a 55-degree angle up here and a 35-degree angle out here, and we'll label the sides A, B, and C. If we want to talk about the relationship between two sides, we have a few different pairs that we could take. We could take A and B as a pair and talk about, like, what's the relationship between A and B, right? We could have A over B, or we could have B over A. We could also examine the relationship between A and C. We have A over C or C over A. And finally, we have B and C, right? What's the relationship between B and C? The way I kind of want to look at this is just from the perspective of one of the angles. I think this is going to simplify the concepts for us, and it's going to allow us to make sense of trigonometry pretty quickly. So let's imagine we are the 35-degree angle right over here. So I'm going to get rid of all this stuff. And let's just imagine the perspective of this 35-degree angle. So the 35-degree angle is looking across at A. So you could say A is opposite. That's the opposite angle of 35 degrees. The opposite side of 35 degrees. B is right next to it, right over here. So B is what we call the adjacent side. So B is adjacent. And finally, C is what we call the hypotenuse. That is the side opposite the 90-degree angle. So it's also the longest side in any right triangle, and that's just always called the hypotenuse. There's a Key and Peele video where they say they want to get high on hypotenuse. I'll link that in the description. So C is the hypotenuse. So trigonometry comes with this cool acronym that probably a lot of you have heard called SohCahToa. I'm going to write this one out for you, and I'm going to explain how this applies to our 35-degree angle. Okay, so we have this acronym, SohCahToa, that tells us that sine describes a relationship of opposite over hypotenuse. So let's get rid of a bunch of this stuff, and I'm just going to rewrite SohCahToa at the top just so that we have that as a reference. What trigonometry does is it gives us labels for these different relationships. So sine describes the opposite over the hypotenuse. And if we're thinking from the perspective of 35, sine of the 35-degree angle, right, its opposite is A, and its hypotenuse is C. So sine of 35 is going to be A over C. Now, cosine of 35, that describes the adjacent over the hypotenuse. So that would be B over C. And finally, tangent of 35 would be equal to opposite, which is A, divided by adjacent, which is B. This all comes from the acronym, right? Sine is opposite over hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. Now let's talk about the perspective of the 55-degree angle. So sine of 55 is the opposite of the 55-degree angle. Which one is opposite 55 degrees? Well, if we look across the triangle, that would be B. So now B is our opposite angle because now we're looking from the perspective of the 55-degree angle at the top of the triangle. So you notice how when we shift perspectives of which angle we are coming from, the opposite and the adjacent angles are going to flip. The hypotenuse is going to stay the same. So now sine of 55 is going to be B over C. B over C. Let's scroll. Cosine of 55 equals A over C, and tangent of 55 is B over A, right? Because opposite over adjacent. I hope that's clear. And you might have noticed that the cosine of 55 is the same as the sine of 35. And the cosine of 35 is the same as the sine of 55. That is always going to be the case in a right triangle. The other two angles, the cosine of one is going to be equal to the sine of the other, and the sine of one is going to be equal to the cosine of the other. That's a property that will always be true in trigonometry. One other thing that I just want to say before we jump into two problems to solve is this. Sine of 35, if you plug that into a calculator, make sure you have it set to degrees. If you plug in sine of 35 into a calculator, you're going to get sine of 35 is approximately equal to 0.57. And remember, sine of 35 in our situation that's A over C. So that means that A over C, the opposite side divided by the hypotenuse, is going to be around 0.57. Another way of saying that is that the opposite side, A, is going to be about 57% of the hypotenuse. So it's going to be a little bit more than half the size of the hypotenuse. And that's going to be true no matter how big or small this triangle is. So let me scroll down and kind of illustrate that point real quick. So we could have one triangle like this, right angle 35, 55. And now I'm going to kind of blow this up and say we have a much bigger one, a much bigger triangle with the same angles, A, C, let's just call this A prime and C prime, and this will be B prime, just for completion's sake. A over C is going to be equal to A prime over C prime, which is going to be equal to 0.57, or approximately 0.57. So this tells us that similar triangles, meaning triangles with the same angles, are going to have the same ratio between their sides, between their side lengths. And this is a principle that's taught in geometry, but I've never seen it connected to this idea in trig, that a sine is describing the relationship between two sides, and that relationship is constant when the angle is constant. So sine of 35 is always going to equal to the sine of 35 in any right triangle. Now let's use this stuff to solve a couple of problems. Okay, so our first problem is we have this right triangle where we have a 45-degree angle, and we're trying to figure out what the opposite is, and we're given the hypotenuse. So if we have the hypotenuse, check. We don't have the opposite, and we have the angle. Angle is a check. So which is it going to be, sine, cosine, or tangent? Which one utilizes the opposite and the hypotenuse? So if we go back to our SohCahToa, that would be sine. That would be sine that's utilizing the opposite and the hypotenuse. So to solve this, we have to say sine of 45, that's our angle, is equal to opposite, which is x, we don't know it, over hypotenuse, which is 9. And in order to solve for x, we just multiply both sides by 9, and we get x is equal to 9 times the sine of 45. And if we stick that in a calculator, that's approximately 6.36. So that's how you would solve for an unknown side if you have the angle and you have another side. Now, let's do another problem, this time with an unknown angle. With this one, we have an unknown angle, x. And we're given the opposite side and we're given the adjacent side. We actually don't know the hypotenuse. We could calculate it using the Pythagorean theorem, but we don't need to in order to solve for x. What we need to say is that if we're given the opposite and the adjacent, that should scream tangent, TOA. T-O-A, tangent is opposite over adjacent. So we have tan x equals 12 over 18. Now we haven't actually learned a way of solving this, but you may notice on your calculators that you have this thing that looks like tan -1. We call that arctan. And when we are given the sides but not the angle, and we're trying to use the sides to solve for the angle, we actually use this inverse tan function. What tangent usually does is we give it an angle and it tells us the relationship between two sides, namely the opposite and the adjacent sides. But what if we are given the relationship between the sides and we need to find the angle? Then we have to use the opposite function, which is arctangent. So what we would do is we would put arctan, tan -1, and then put the relationship between the sides, 12 over 18, opposite over adjacent, and that will give us 33.69. 33.69, and that is the degrees of our x. Altogether, we learned what trigonometry does. It gives us relationships between sides based on an angle. It could also give us an angle based on relationships between sides. And we have this convenient acronym SohCahToa that tells us which function, sine, cosine, tangent, go with which relationships between the three sides. I hope this video was super helpful for you guys, and if you like it, remember to like, comment, and subscribe. I really appreciate it. Thank you for watching, and have an awesome day.